Hello.
Okay, so hello everyone, welcome. Can you hear me?
Yes, sir. Yes, sir. How are you, sir?
Alhamdulillah, I'm fine. Thank you.
Yeah. How's your baby?
Yeah, Alhamdulillah, everything is good.
Yeah. Nice, sir. Nice. Once again, congratulations, you, sir.
Thank you, thank you.
Hello, sir.
Hello.
Good to see you.
Yeah, thank you. Okay, just we're waiting 1 minute, then we'll start with this session. Thank you. Okay, let's go. Let's start with this session. So basically, today is our sixth number of class, and today's session I will discuss about that machine learning, how we can easily use the machine learning algorithm. It can be different types of machine learning, random forest or support vector machine or classification criteria. This type of machine learning algorithm, how we can easily implement in Google Earth Engine, and further how we can easily work for the land use, land cover classification or crop classification or other types of classification, how we can easily perform. Today's session I'll try to explain about that. So let's go, just simply share my screen. Can you see my screen now?
Yeah,
Thank you. So let's go. So basically, today's session I try to discuss about that introduction to machine learning in Google Earth Engine. Then how we can easily make the land use, land cover classification map using machine learning, mainly supervised and unsupervised, both of model. I try to explain. Further, for the supervised, I try to explain about that random forest, then card, mainly classification and regression trees, then support vector machine, then minimum distance. So all of classifier, how we can easily use and make the land use land cover classification map, and how to check the land use land cover accuracy assessment. Okay, so how we can easily overall accuracy, kappa accuracy, or producer accuracy, consumer accuracy. We'll try to discuss about that, as well as we talk about the calculate land use land cover classes area, and how to add the legend on Google Earth, legend in land use land cover map, and how to export land use land cover map and work with the ArcMap software. As well as we also try to discuss about that how we can easily improve our accuracy. Okay, sometimes when you to make the land use land cover classification map, you can get the very low accuracy. So that's why we also need to learn about that how we can easily improve our accuracy and get the more better classification result. Okay, so let's go. So just simply open my slide. So let's go. So first of all, machine learning. So basically, machine learning is a branch of artificial intelligence and computer science that focus on the using data and algorithm to enable artificial intelligence to imitate the way the humans learn. So gradually improving the accuracy. So basically, we find out the three types of machine learning in Google Earth Engine, mainly supervised, unsupervised, and regression. Okay, so this type of classification, we can easily perform the Google Earth Engine free. But Google Earth Engine is also provide some paid model such as deep learning, CNN model or ANN model. So this type of paid model also provide the Google Earth Engine, but freely we can use this type of supervised, unsupervised, or regression. In the supervised, we can easily apply for the random forest or classification trees or support vector machine or minimum distance algorithm. So this type of algorithm we can easily apply. And unsupervised, mainly you can use here the k-means clustering algorithm we also use. Okay, so basically supervised and unsupervised, a lot of uses for the machine learning to make the classification or regression. So basically supervised classification is one kind of classifying technique. It's used for when you want to take the training sample. Suppose supervised classification, you must need the training sample. Suppose I want to make the classification of land use land cover map for, I want to classify build up area, water body, vegetation or barren land. You must need take the training sample of each sample or each classes. Okay, so without training sample, we cannot perform the supervised classification. But unsupervised classification, you don't need to take any kinds of ground truth data, or you don't need to take any kinds of training sample. Okay, so without taking any kinds of training sample, we can easily perform the unsupervised classification. But supervised classification, you must need take the training sample for classification or regression. You must need take the training sample. So both of process, how we can easily perform, I will show you the further. And regression, basically it useful for regression model to predict anything, water quality or present forest cover or present cloud cover or crop yield prediction. So these type of things we are also using the regression. Suppose based on NDVI, we can easily predict for the crop yield, or based on precipitation, we can easily predict for the crop yield. So this type of parameter we can easily use, and further we are apply the regression model, and further we also predict the different types of things using the machine learning model in Google Earth Engine. So first of all, we talk about the classifier. So classifier is mainly, it's one kind of algorithm. Suppose classifier random forest is a classifier, or support vector machine is a classifier, or minimum distance, it's one kind of classifier. So the algorithm which implement the classification on a dataset is known as a classifier. So support vector machine, random forest, or classification trees, all of model or all of algorithm known as a classifier. And there are the two types of classification mainly we can do. One is the binary, another is the multi-class. Suppose binary classifier, we are just take only for the two outcome. Okay, all time we can get the only for the two outcome for the binary classifier. Suppose yes or no, male or female, spam or not spam, cat or dog. So outcome all time we can get the two for the binary classifier. And multi-class classifier, we can get that more than two outcome all time. More than two outcome we can get it called as a multi-class classifier. Suppose land use land cover classification, or crop types classification, or classification of types of music. Lot of example are available for the multi-class classifier. Some algorithm work very well for the binary, and some algorithm work for the well for the multi-class classifier. So it's the different. Suppose support vector machine algorithm is work for the binary classifier. Suppose you want to make only for the two class. Suppose land use land cover, you want to make only for the forest and deforestation. Forest and deforestation, you can easily get that high result when you want to apply the support vector machine algorithm, because it's a binary classifier. In binary classifier, we can get that more better result than other classifier for the binary support vector machine. When we apply the support vector machine, we can get the more better result for the binary classifier. And multi-class classifier, we can easily apply the random forest classification, as well as also we can apply the cart classification. Mainly cart is the classification and regression trees algorithm. So further let's discuss about the practically. So let's go. So when you want to make the land use land cover classification map in Google Earth Engine, we have to follow some step. First of all, you have to selecting your region of interest. Suppose you want to make the land use land cover classification map for Dhaka city. So you have to make a Dhaka city boundary shapefile and then import it. So this is your region of interest. So which area or which boundary you want to make the land use land cover classification for, just simply import and then selecting your region of interest. Second, you have to choose and filtering your image collection. Suppose if you want, you can use either the Landsat or Sentinel. Both are the same approach when you want to make the land use land cover classification map. Just you choose your image, Landsat or Sentinel, then filtering the image collection. We already know about the image filtering the image collection, different approach we already learned for image filtering. Third step, we need to collect the training point because it's a supervised classification. In the supervised classification, we just take the training sample for each classes. Suppose you want to make the land use land cover map for and classification, crop or build up, water body, then barren land or wetland. So all of training sample you collect from your satellite imagery. So how we can easily collect the training sample? Further, I also discussed a lot of briefly. I described about that, and then we merge all of training sample, all of training point. We merge. Further, we make a training data set by sampling regions. So in this time, in this data set, basically this data set stored the different types of values, bands values, different types of band values for each training point. Suppose I want to take training point for water body, vegetation, build up, and barren land. So all of training point also extract the information for the different types of band, such as red, green, near infrared, short wave infrared 1. So all of bands, all of training sample extract the band's pixel value. Okay, and this is my data set. This band pixel value or a spectral signature. This spectral signature is my data set. So further this data set I use and then apply the machine learning, and then we can easily make the classifier. And then we have just create the classifier using this data set, and we classified the image. And in the meantime, we also need to take the data set such as suppose 80% data for test our model, or 80% data for train our model, and 20% data for test our model. So we just split the data set, and for the 80% data we just use for classifier, and 20% data we use for checking the accuracy or performance of our model. Okay, for checking that, and create the classified image and display the result. Further, we calculate the confusion matrix for accuracy assessment and calculate the area of each classes. Okay, so let's go practical example. I will show you that one by one. So let me open my code editor. So first step, we have to import our study area. Suppose in this time, this is my study area of Dhaka city. So here I already imported my boundary. So now I want to use, and then further I want to make the land use land proper classification map for the Dhaka city boundary. So just I simply import. So now I can see it will be imported. And further, I want to give a variable name. It's the default table. I put the name suppose RY, or you can put any name. And further, I want to display this layer of my shapefile. Suppose map.add layer, and then RY, and also focus the center view of this shapefile. Map.center object. Object is mainly RY. Put the zoom level suppose 10, and click the run. So now it visualizing my study area. Okay. So this is my region of interest, and for this area I want to make land use land cover classification map. So now my first step is done. So now talk about the second step. Second step, we are just choosing and filtering the image collection. In this time, if you want, you can use that the Landsat image, or if you want, you can also use that the Sentinel imagery. It's totally depend on your project. Okay, sometime when you want to work for the historical land use land cover classification map, then you must use the Landsat imagery, because in year of 1990 or 1980, there is the no Sentinel imagery. So for that, for historical land use land cover map, you must use here the Landsat imagery. But for the Sentinel, we can get the imagery from year of 2015 or present time is also available. So for that, you can also use here that Sentinel imagery because Sentinel is high resolution than Landsat. Sentinel is only for the 10-meter pixel and Landsat is a 30-meter pixel. So that's why Sentinel is more better land use land cover map we can get. But historical land use land cover map, when you create, you must use the Landsat imagery because Landsat imagery is available for the historical. We can get the image from year 1973. From 1973, we can get all of Landsat imagery. For the present time is also available. Okay, so let's I want to use for the suppose Sentinel. So just click on the browse data catalog. And further, I try to open my click on the Sentinel. So here I can get the all of Sentinel image collection. Here you can see, yeah. So I want to use here the multispectral instrument. It available from 2015. And here you can see two types of image, top of atmospheric and also get a surface reflectance. So basically surface reflectance, it's better use for land use land cover classification map. We can get the more better result when you want to use the surface reflectance because it's a level 2A and also orthosified atmospherically corrected surface reflectance data. So that's why it also more better than top of atmosphere reflectance. Okay. So just I use this imagery and further I want to make this classification of land use land cover map. So first of all, this is my imagery. So this imagery I want to import in my code editor. We already know about that. Okay, basically for the second days, I also try to discuss about that. I simply copy and then further just paste here. And then I give a variable name. Suppose I put the name is that image or you can put any name. So now this variable stored this image collection. So now this image collection I want to filter. So how I can filter? We already know about that. So first of all, where I need the image? I need the image for Dhaka city. So I put here the filter bounds. And where I need the Dhaka city and Dhaka city is stored in the ROI. Just put here the ROI. Then how I need the image? Suppose I need the less than 1% cloud cover. So put here the filter metadata and call the, you can see about the image properties. I choose suppose cloud pixel percentage. And I put here that less than and set the value for 1. And further when when you need the image, when. So for the when we put here the filter date function and put the specific time period. Suppose I need that image for year of 2024 01 from year of 2024. You can check the last time period about that. Here you can see this imagery is available for the last time 0711. Okay, so I put at the 0711. And now further, if you want to check how many images is available, suppose just image and use the size function. So now it computing how many images are available for this collection. We can get then 15 images. Okay, so now if you want, you can also take for the single image and then further make the work. But in this time, I want to make the all of images and create the median composite. Actually, it's depend on your project work. Sometime you want to work for that single date image, then you can just take the single date image. Sometime when you want to work for the big study area, then single tiles is not enough. Then we need to create the median composite and work with that. So in this time, I take the median composite. So just put here the median. And this median, I want to clip with my study area, which is ROI. So now display this imagery. So just put here map.add layer and call this image. So just click run. So now it added this imagery. Total 15 images, median composite. It created this imagery. We can get this type of imagery. It's the default visualization. So you can see we can get the totally black color image. So just I try to click on here. And here you can see this wavelength, this spectrum value is not scaling. It's about the long value. So that's why you also need to scaling this type of value. Then we can get the better spectral signature value. So for that, here you can see they already provide some scale. In the bands, you can see they're already provided some scale 0.01, and all of bands are the same scale. Okay, so for that I simply copy the scale value, and then this scale value I just simply multiply with my imagery. So just put here that multiply this value. Okay, so now further click the run. So now we can get that reprojected scale value, and we can get the proper spectral signature value. So now try to check again. Suppose I just click on here, and further I put here the suppose red band, then green band, and also put here that blue band, and then custom stressing 98% for better looking. So now I can get, you can see 0.04 or 0.1. So it's the sequence, is the range we can get. But further, without multiply this value, we can get the very high value. Okay, so now it reprojected the scale value. So just apply it. So you can see we can get this type of imagery. So this is our satellite imagery we can get. And just I import the visualization. When I click on the import, a new line of code added in my code editor. Just simply copy from here and paste after the object name. So this is my image, is my object name. So just I paste here. So now this visualization is set with my imagery, and I also put the layer name, suppose imagery. So click the run. So now my image collection is done. So this is my second step. Okay. Second step, mainly we choose and filtering our image collection. So now I can get this type of imagery. And now we talk about the third step. In the third step, we need the training sample. Okay. So in the third step, we take the training sample for these classes. So in this time, from this satellite image, which class you want to classify it? Suppose in this time I want to classify it for water body. Suppose build up, then vegetation or barren land, I want to classify it. Or if you want, you can also put the more classes. Then you also need to take the more training sample for each classes. So now how I can take the training sample? There are the two ways. If you want, you can visit your study area and you can take the specific latitude and longitude. It's very important for the crop classification. Suppose you simply visit your study area and you can take some training sample for each crop. Okay. And further, these things you can easily import in Google Earth Engine in a CSV file. Suppose in your CSV file, you take some training sample, latitude, longitude for water body or rice crop or any specific crop. So for that, you can simply import these things from here. You can see new and CSV. Okay. So this CSV file you can simply import. Then it shows as a point. So just simply sort this file, and further you can also add the property. In the property name, suppose put here the class and set here the value for 0. Okay. Then you can upload it for the rice crop. Then upload it. So then we can get all of rice training sample, and we set the value is the 0. So all of 0, it indicating about the rice crop or any other crop. Suppose you can for that jute or any other crop. Just simply import look like that. So it's very important for that crop classification or crop types classification. We need the ground truth data or ground field data. Then we can easily make the classification. And this is the way to import the CSV file. So you make a CSV file. Suppose you can make a CSV file for rice. You can make the another CSV file for jute, another CSV file for sugarcane, another CSV file for another crop. And then one by one, you simply import in here. Just you can put the class and put the value for 0 for rice, 1 for suppose jute, 2 for sugarcane. So just import one by one, then it will be okay. So this is the way for ground truth data. So now, in this time, suppose I don't have any kind of ground truth data. So then what I can take the training sample. For that, we are also using the different types of band combination. So in this image, we can easily apply the different types of band combination and we can easily detect the different types of feature. So in this time, it's called the natural color. Okay, so it's called the natural color or RGB, mainly true color composite, true color band combination. So here you can see we can get this type of things. We can identify it's a build up or building or settlement. We can get this type of green, mainly it's the vegetation or barren land. Okay, but if you want, you can also use that the different types of band combination and identify the different types of feature. Suppose one kind of example, just click on here. I want to put here the another band combination. Suppose I put here the near infrared B8 for near infrared, then put here that red and blue custom staging suppose 98%, and then apply. So now it's called the false color band combination. And when you want to use this type of band combination, then we can get the water body as a black color or dark color. So this type of black color identify about the water body. And green and this type of red color, it's identify about the vegetation all time for any region. When you want to apply the near infrared, red and blue, then always water will be black color or dark color. Okay, and vegetation will be this type of red color. Better red color identify about the better vegetation. Okay, and this type of gray color, you can see, you can also get this type of gray color. It's identify about that barren land. Barren land we can easily get from here. You can see this type of thing, the barren land you can get from here. This type of gray color, and this type of black color or dark color identify about that water body. Okay, and this type of red color identify about that vegetation. Okay, so all time for any region, when you want to apply the near infrared, red and blue, we can get this type of things. As well as suppose I want to put the another band combination, it's called that short wave infrared one. Then I put here that near infrared and put here that green. It's testing 98%. So now just I put this band combination here again, so I can get another visualization. So in this time we can get the vegetation as a green color. You can see this type of things is the green color is the vegetation. This type of things is that a barren land. Okay, this is the barren land, and water body show as a black color. We can easily get it from here. Okay, not only for that, you can simply search on the Google, then you can get a lot of band combination, and using this band combination you can easily identify different types of feature on the surface, as well as also for different types of mineral or different types of things we can detect using the different types of band combination or band ratio. So I simply search here, suppose Landsat 8 band combination. So this is the website. From this website you can easily get a lot of things, how it will work, different types of band combination, and we can easily identify for the different types of feature. So here you can see here you can see this is that natural color, mainly red, green and blue, and it also applicable for the Landsat or Sentinel. Both of imagery is the same. When you apply the red, green and blue, then we can get the natural color band combination. So here you can see it reflected the close what our human eyes can see. Healthy vegetation show as the green, unhealthy flora is the brown, urban feature appears the white and gray, and water is the dark blue or black. So this is the band combination red, green and blue when I apply in here. Further also you can see about that color infrared. So basically it's the near infrared, red and green. When I apply the near infrared, red and green, then we can get this type of band combination, and it's mainly useful for the vegetation analyzing, as well as we can get the red have better vegetation or healthy vegetation. Okay, red, and dark areas are water and urban areas are white. We can get when I apply this type of thing, we can get this type of thing. So we can easily detect it's a water body, it's a this type of it's the urban or it's a vegetation. You can easily identify. Also you can see the another band combination, it's a short wave infrared. So these things is very important to, we can see about that tracker shades. Green indicate the denser vegetation, sparse vegetation has the light shades, urban areas are the blue, and soils have the various shades of brown color. And you can see this is very important for that agriculture or crop classification. Basically, in the crop, we can get when you apply the 652, basically short wave infrared 1, near infrared, and blue. When you apply, then we can get this type of things. Here we can easily identify for the crop land or agricultural land. So basically, what is the difference between the agricultural land and vegetation? In the agricultural land or crop land, we can get a pattern. It can be rectangle pattern. You can see this type of, we can find out this type of rectangle pattern. Okay, but for the vegetation, here you can see it's a vegetation. Okay, there is random pattern. Okay, this is vegetation, we can get the random pattern. But crop land or agricultural land, we must get this type of rectangle, or we can get the specific pattern. But for the vegetation or trees, we don't get any kinds of pattern. So it's a randomly distributed. Suppose we can see it's a vegetation, we can get this type of things. But for the crop land, we can get this type of square pattern or rectangle pattern we can get when I apply this type of things. But vegetation shows as a randomly distributed. So then I can easily identify it's a vegetation, it's a crop land. We can easily distribute between those things. Also, you can say about it's very important for the geology. So we can easily apply this type of band combination, short wave infrared 2, short wave infrared 1, and blue. This band is particularly useful for identify for geological formation, lithology feature, and faults. We can easily identify. As well as you can see the bathymetric, we can also identify. Using this, we can easily identify when I apply the 431, basically is the red, green, and coastal bands. Okay, one is the coastal aerosol band. Coastal bands, when I apply, then we can easily get it. So this coastal band is useful for the coastal or bathymetric or aerosol studies because it reflects the blues and violets. So estimating for the suspended sediment in water, we can easily identify about that. So not only for that, also you can see about that other types or barometric. Also you can see about the vegetation index. We already know about the NDVI or moisture index. So different types of band combination and different types of index also use. Not only for that, you can simply search here, suppose mineral exploration. Just simply search here using Landsat. So now we can get the different types of index or different types of formula to identify for the different types of mineral. We can easily detect from here. You can see band ratio. Just simply open it. I think some network issue just. Okay, so here you can see different types of band ratio for Landsat and Sentinel-2, such as clay and carbonate alternation. We can easily visualize when you want to use this type of band ratio. So basically 6 is a band, mainly short wave infrared 1 and short wave infrared 2. When you put this short wave infrared and short wave infrared 2 ratio, then we can easily identify about the clays and carbonate alternation or fish silicate. We can iron silicate we can easily get when I put this type of band ratio, Also you can say iron oxide or ferrous iron. Okay, so this type a lot of things you can easily get. Also you can see about this is another things about that band ratio. So you can see the mineral index or chloride or this type of different quarters index. So this type of things we can easily apply. Okay, and then we can easily take the different types of mineral or things we can easily identify from the surface, such as NDVI index, or there's a lot of things is available in remote sensing. We can just use this type of things and we can easily detect the different types of identify for the different types of feature. Okay, so now in our code we take the training sample. Okay, so how I can take the training sample? Suppose in this time I want to make the classification for water body, build up, then settlement or build up, then barrel length. So for that I need the training sample. So how I can take the training sample? Just I simply click on here, you can see the marker, add a marker, and you can see the geometry. Just click on the geometry and put the name. I put the name suppose water, and further import as feature collection and put the property name. I save the property name suppose class and set the value for suppose 0. So all of training point for water I put the name as a 0. Okay, so then click to the okay. So now further we are just take the training sample for water. Just click on the water body and take the training sample. Suppose I just click on here, and how much training sample I need to collect for each sample. So basically it's different on your study area. Okay, as well as it also depend on your accuracy. Sometime you can get the very low accuracy, then you need to increasing the training sample to fix and also increase the accuracy. But if first time you try to take more than 30 and then run your model, and further if you take the low accuracy, get the low accuracy, then further also increasing or decreasing the training sample to increasing your accuracy. So first of all you try to add that more than 30 and then you run your model. Okay, after check your performance, further you take the decision to increasing or decreasing your training sample. So in this time you can say I take this training sample for water body. Suppose I take the 31 or 32. So one is done. So water is done. So further I take the new layer and take the another classes. Suppose I put here vegetation. Same process, import as feature collection. I put here the property always same. I put the class as a variable, but when you put the you have to put the same property name all time for all of classes, but value will be changed. Suppose I put the vegetation, value for 1. So now all of training sample I just put the name or I set the value for 1. So now here you can see we can get this type of green pixel value. This green pixel value identify about the vegetation. So just I take the some training sample for the vegetation. Just click on here. You can see now it will be take. Just I take some training sample. First of all, I take the 30, and further if I check my model performance, then I need to increasing or decreasing my training sample after checking the accuracy. Just you take the training sample, look like this way. Let's just take training sample for that vegetation. And further, I take the another class. Suppose just I click on the new layer, and I want to take for that suppose barrel length. So just click on here and put here and further just parallel and just feature collection property name is the same because I put here the class. So just I keep the same name and set the value for 2. Okay, so first of all I put here the 0, then 1, and then 2. If you want, you can also put here the 1, 2, 3. That is no problem. But in JavaScript programming, it counting start from the 0. So that's why it also use better to use the 0. But if you want, you can also put the 1, then 2, then 3. It also okay. There is no problem. So now I just select on the barrel land, click on here, and further I take the barrel land training sample. So just I click. And you can see in this time, when I use this type of band combination, then I can get this type of things. Here you can get the 2. Here you can see this type of gray color. This type of it's also barren land, but also wetland. But this type of things is the barren land, dry barren land. But you can see this type of things is that wetland. This type of color, reddish color, it's identified about that wetland, wet barren land. But this type of identify about that dry barren land. So if you want, you also make the more classes, then you also take the another training sample for that wetland, wet barren land. Then it also more better. In this time I want to keep the same classes, but I just merge all of barren land, dry, and wet. I just merge it and make the one class for the barren land. And it's very easy. I can do it because I already make this map for the study area. But at a first time, when you want to work for any project for any area, you try to use the different types of band combination. Okay, in this time I just keep only for the one band combination. I take the training sample. But when you want to make this your own project for any unknown area, then you try to use the different types of band combination and then take the training sample. Then you can get the more accurate map. Okay, so these things I already do, so that's why I just keep only for the one band combination and I take the training sample. But for the new project or new study area, when you work, you try to use the different types of band combination. Okay, so here you can see this is the different types of band combination you try to use and identify for the different types of feature. Then you get the more better result. So now I take the barren land. Okay, so I take the look like the barren land, and finally I want to take suppose build up or settlement. Just I click on the new layer and then click on here, and property I put here suppose build up, then feature collection, and property I set the property name is the class, and I set the value for 3. Okay, so here you can see 0, 1, 2, and 3. So now suppose I take the another band combination, click on here, and then I set here 2 color composite, just red, green, and blue, RGB color I put, and further custom stressing 98%, and then I just apply it. So now I can get this type of map, this type of visualization. So now I just take the training sample, this type of things is the barren land. So just I take this type of things, it's a build up. Okay, the build up. So just take this training sample from here. So just I take the training sample of the barren land. Okay, just I take the training sample barren land. Okay, so this is the things to collecting the training sample. Okay, all of classes, which class you want to classify from your satellite imagery. So now after taking the training sample, we have to extract the band pixel value. Suppose this point, extract the band pixel value. All of band pixel value extract. So this point, extract the band pixel value. So for doing these things, we have to apply the third step. So just we put the fourth step. After training sample, we have to just merge. So this is the fourth step. after taking the training sample, we have to merge. Take a variable. Suppose I put the variable in the samples and I merge all of training sample together. Suppose water, it merge with vegetation, but it's merged with barren, it merged with build up. Okay, so all of training sample I just merge and store it in this variable samples. So now for that I just print it. So just use here the print function and then put here the samples, click run. So now it computing how much training sample I take for this time. So now it computing the total training sample. So in this time we take the total 141 training sample, and it's a supervised classification model. So that's why you can see I make the pre-categorized data. Suppose this 141, it's a pre-categorized. Suppose here you can say just click on here and check the property. We can get the class 1. Okay. So this class 1, it's a label. Okay. It's a label. And what is the class 1? You can see class 1 is the vegetation. Because I put here the value is the 1. So this training point used for taking the spectral signature for vegetation, because its class is the 1. So also you can see about that other. Suppose I click on here. So here you can see this property class 2. So this it's a class 2. It means that it's a barren land. And this training sample extract the spectral signature for the barren land. So it's totally label data. Label. We keep the pre-categorized data. So now for all of training sample, I want to extract the band's pixel value. And which band I want to use for that. So just I take a variable, suppose bands, and all of bands, I just make a list. Suppose here you can see in my satellite imagery, this satellite imagery is already available, this type of band. So you can see the B1, B2, B3, B4, B6, B7, B8, B8, B9. All of band is already available. So in this time, I just use only for the 10-meter pixel and 20-meter pixel band for getting the more better accuracy. So 10-meter mainly you can see B2, then B3, B4, then B5 is the 20, B6, B7, B8, okay, then B8A. Also you can see about that B12, B11 and B12, okay. So this type of band I want to use and extract the spectral signature for each points. So let's go try to do it. So just I put here that B2, I just make a list, B3, B4, then put at the B5, B6, B7, B8, B8A, then put at the B11 and B12. Okay, so this is the bands, and all of training sample extract all of those band pixel value, okay, which I set in here. So now let's go try to extract the band pixel value for each point. So for that, it's our fifth step. Just I put the variable name, suppose training, and then further I call my image. Okay, basically this variable image stored this image, and I put here the select function and selecting these bands. So now this variable bands is stored all of bands, and I want to extract the spectral signature or band pixel value. So for that, use a function sample regions and put all of argument. I just make a dictionary. So just curly bracket start and also curly bracket in. Collection mainly it's your training sample, all of training sample. So all of training sample is stored in the this variable samples. I simply copy and paste here. Okay, and properties. So here you can see properties, and we put the all of property is the same for the class. Property name we put the class, and now here you can see it show about the properties. So it's the plural form. Okay, so when you can get this type of properties, also you can see about the geometries. So it's one kind of plural form. So these things when you want to put, we have to put the square bracket because it's not a single value because it's a plural form, and all of property is the same name. So that's why we are just put at the square bracket and put at that property name class, and scale I consider for that 10 meter, and remove all of those things from here. So now we are just print that. So print this training. So now it extract all of bands pixel value. So click the run. Just click on here. You can get all of band pixel value. Just click on the feature. So here you can see all of total 141 points, and each point extract that all of band pixel value. Suppose here you can see we can get it B11, this value B12, B2, B3. So all of band pixel will extract from here. And what is the class? Class the one. One means it's that vegetation. Okay. So all of those things for the vegetation we can get from here. As well as suppose you can check this training point. Just click on here. You can see we can get all of band pixel value. And what is the class about that? You can see this class is that class 3, and class 3 is mainly for that build up. Okay, because 0, 1, 2 and 3 is the build up because we set the value for 3. So now we can get the pre-categorized data, as well as we also make the spectral signature for all of training sample using all of bands. So in this model we are just keep only for the internal band. This type of band is already available in your satellite imagery, but for our improving our accuracy, we also need to add the some external band, such as we need to extract suppose NDVI band. We need to also put at the NDWI band. We need to put at that EVI band. For the different types of project, we have to set the different types of band, different types of external band to increasing our accuracy. Okay. So further also let me show you that how we can easily work with for the external band, and it's very helpful to improving your accuracy. And we can get when I add this type of external band, it also increasing, it extract the more pixel value. Suppose when I put at the NDVI, what happened? Then all of training sample also extract the NDVI pixel value. When I put at the band for EVI, what happened? All of training sample also extract the EVI information, EVI pixel value. Okay, and then we can easily get that, we can create the big data set, and we can easily distinguish between the each classes. Suppose you want to make the land use land cover classification for the vegetation, cropland or trees. In this time, all of band is the same value for the vegetation or cropland or trees. But when you put at the EVI or also put at the NDVI or SAVI or any other kinds of vegetation index, then it will be distinguished. We can easily differentiate the vegetation, forest or trees. Such as another example, build up and barren land. So build up and barren land, this spectral value is almost same. For differentiate for the build up and barren land, we have to use at the one band. It's called that NDBI, mainly normalized difference build up index, as well as also used for the BI index, mainly barren land index. So when you use this type of index, we can easily differentiate the build up and barren land. We can easily differentiate. We can easily create the distinguish between them, and we can easily get that more better map. Otherwise, build up is also mixing with the barren land. Barren land is also mixing with the build up. So then it not get the better result. So these type of things we also discuss further later. So first of all, we try to make the map only for this internal band, and further we will discuss about that how we can easily use this type of external band and work with more better map. Okay, so now this is our data set. This variable is stored in the data set. Okay, so now we can create the data set. So now after creating the data set, we have to just spill the data set, okay, in the two way. Suppose, okay, before that, any question you can ask me for this time. Any question or any confusion for this code? Or any doubt? Okay, I think everything is good. And further, you face any problem or any question, just you can ask me, no problem. Okay. So now we create the data set, and this data set we want to spill. Suppose in this time it's vary. Suppose some paper you can check 80% data they are used for train, and suppose 20% data used for testing. Okay, some paper 70% data they are used for train, and 30% data used for testing. So it's different. Okay, so we just spill the data, full data set, 70% for train and 30% for testing. Okay, this 70% data we use for train our model, and 30% data we use for check our model performance. Okay, so let's go try to do that. Just take a variable, and these things we can do randomly. Okay, we can do it randomly. Spill the data set, 70% data, train our model, and 30% data, test our model randomly. So now this training, this variable training is stored in our full data set. And this data set, I want to spill 70% and 30%. So for doing this thing, just I take a variable, suppose data set, and I call this training. And I put here that random column. Okay, so basically this random column function randomly distributed this data and stored it in this variable data set. Okay, and then further this data set I filtered 70% data and filtered 30% data from this data set. Okay, for train and test purpose. So for doing these things, just take a variable. Suppose I put the variable name is that train set, and I call the data set